Hello friends, in this video we will discuss the chemistry of non-aqueous solvents. This video will cover classification of solvents, properties of solvents, leveling effect, type reactions in solvents, chemistry of liquid ammonia, liquid dinitrogen tetroxide and anhydrous sulfuric acid with respect to their properties, solubilities and reactions. Non-aqueous solvent is a solvent other than water. The examples of non-aqueous solvents are liquid ammonia, liquid sulfur dioxide, sulfuryl chloride, dinitrogen tetroxide, hydrogen fluoride, pure sulfuric acid and other inorganic acids. These solvents are used in chemical research and industry for the reactions. Classification of solvents. First, classification of solvents based on proton donating and proton accepting ability. Second, classification of solvents is based on polar and non-polar nature of solvents. Classification of solvents as aqueous and non-aqueous solvents. Types of non-aqueous solvents. First type, protonic and non-protonic solvents. The solvents from which protons can be derived are called as protonic solvents. For example, water and sulfuric acid. The solvents from which protons cannot be derived are called as non-protonic solvents. Liquid sulfur dioxide, benzene and chloroform. Protic or protonic solvents. These solvents are again subclassified as acidic or protonic solvents, basic or protophilic solvents and amphoprotic or amphoteric solvents. Second type is aprotic or non-protic solvents. For example, benzene, CHCl3, CCl4 and SO2. Second type of solvents is acidic, basic and amphiprotic solvents. The solvents which have a tendency to donate protons are acidic in nature and are called as acidic solvents. For example, acetic acid and HF, hydrofluoric acid. The solvents which have strong tendency to accept protons are basic in nature and are called as basic or protophilic solvents. For example, liquid ammonia, pyridine, etc. The solvents which neither have tendency to gain nor to lose the protons are called as amphiprotic or amphoteric solvents. Examples of these solvents are H2O, water, and C2H5OH, ethanol. Third type of solvents, ionizing and non-ionizing solvents. The solvents which are capable of undergoing self-ionization are called as ionizing solvents. Examples are H2O, NH3, SO2, etc. The solvents which do not ionize at all are called as non-ionizing solvents. Examples are benzene, hydrocarbons. These solvents are non-polar in nature. Physical properties of solvents. We consider some physical properties of solvents such as dipole moment, dielectric constant, electrical conductance, viscosity and proton affinity. Dipole moment. Dipole moment is the product of charge and distance between two charges. Higher value of dipole moment, greater is the polarity of solvent. Electrical conductance. The ionizing solvents are self-ionizing. Electrical conductance give idea about extent of ionization. Greater the ionization, acid-base reactions can occur easily. Next property is viscosity. Some solvents are highly fluid, such as water. Some solvents are more viscous, such as sulfuric acid. Low viscosity solvents can be handled easily than more viscous solvents. Proton affinity. Proton affinity of protonic solvent influence the behavior of solute. Ammonia has greater proton affinity than water. Acetamide behaves as weak acid in water and it exhibits acidic properties in liquid ammonia. Types of reactions in solvent. Some chemical reactions are influenced by the nature of solvent. First, precipitation reaction. Second, salt formation reaction. Third, solvolysis. Fourth, solvent formation. And fifth, redox reactions. Precipitation reactions. When two solutions are mixed, precipitate is formed. The reaction depends upon solubilities of products formed in a particular solvent. Solubility depends upon solvation energies of ions in solvent. For example, in water, barium chloride is mixed with silver nitrate to give AgCl precipitate. When aqueous barium chloride solution is treated with AgNO3 solution, we will get AgCl precipitate. In liquid ammonia, AgCl mixed with barium nitrate give barium chloride precipitate. NaOH is highly soluble in water and can get precipitated in liquid ammonia. Ammonium sulfate is soluble in water and insoluble in liquid ammonia. Copper sulfate is soluble in water while it gets precipitated in acetic acid. Second reaction, salt formation reaction. When acid reacts with base, it gives salt and solvent. For such reactions, the acids and bases must exist in solvent. For example, when phosphonium salt is dissolved in water, pH4 plus ion does not form but it loses proton to solvent to form phosphine. While in strong acid HCl, pH4 plus ions are formed. Sodium uranide. If NaOH is added to urea in aqueous solution, OH minus ions cannot take a proton from weak base urea. However, if the reaction is carried out in liquid ammonia, the base sodium amide will rapidly remove a proton from urea and sodium uranide will form. Solvolysis. The reaction in which solvent molecule reacts with solute split into two parts which may become attached to the solute molecule. Solvolysis process causes increase in concentration of either cation or anion, which is characteristic of autoionization of solvent. The solvents which do not undergo autoionization are unlikely to participate in solvolysis reactions. Solvolysis in water is called as hydrolysis. The concentration of either H plus or OH minus increases due to autoionization. Solvolysis in ammonia is called as ammonolysis. The concentration of either NH4 plus or NH2 minus increases due to autoionization. So, when solvent get dissociated into cation and anion, it is called as autoionization. Water get ionized as H plus and OH minus. Solvolysis in acetic acid is called as acidolysis. Solvolysis in alcohol is called as alcoholysis. Solvent formation. If a solute is dissolved in solvent and excess of solvent is removed, the solid product is covered. So see, if we dissolve a solute in solvent and excess of solvent is removed, then we get a solid product. This solid product contains number of solvent molecules attached to the cation, anion or neutral molecules of solute species by various types of bonds such as coordinate covalent bond, hydrogen bonding or ion dipole interaction. Solvation reaction in water is called as hydration and the solvate form is called as hydrate. Solvation reaction in ammonia is called as ammoniation and the solvate form is called as ammonia. These are some examples of solvent and solvate. The ammonia is a solvent and this is a solvate, NH3BF3. Solvation of cation occurs through ion dipole interaction between positive and negative end of solvent dipole or coordinate bonds in which solvent molecules share electron pair with cation. Solvation of anion occurs through ion dipole interaction between positive and negative end of solvent dipole or hydrogen bonding in case of ammonia, water and HF. Solvation of Na plus and Cl minus. See, Na plus ion is solvated by H2O molecules. And this is solvation of Cl minus by H2O molecules. Redox reactions. Same type of redox reactions occur in aqueous and non-aqueous solvents. Water is susceptible to reduction, hence strong reducing agents cannot be used in aqueous system. However, oxidation reactions can be carried out in aqueous medium. Ammonia is susceptible to oxidation, hence reduction reactions can be carried out in ammonia.